Hello guys, a very happy morning to every one of you. And guys, today we are just going to start one of the wonderful subject. From this production engineering only, I just become a huge fan for Mandal. Literally, for myself, Mandal sir is one of the best sir in the world. I think so, because he is such a great and wonderful sir. Because if it means if I want to tell means I will just keep on continuing and I will just speak for next 1 hour. So literally, in my point of view, Mandal sir is one of the best sir in the world. Okay, and the most interesting thing according to him is jugaad. Everything in the jugaad way. It means a simple made it easy. It means simple, just as use simple technique and made it finish. So like that kind of thing, the sir will definitely do. Okay, so without wasting time, let us get started. Okay, so the first thing is production engineering. So here I am just going to tell detail about the production engineering. So in my point of view, and as well as the little bit of study also I will just do, and according to that I will just explain to you each and every perspective. Okay, so I think so you got the point. So without wasting time, let us get started. Okay, so production engineering means, what is production engineering? I think so you would have known. It means manufacturing of a simple material and as well as complex material. So according to which case we are just manufacturing, that's called as production engineering. Okay, so let us start. So you can see first one, it means manufacturing and versus production. So manufacturing is a process of converting raw material into finished product. Okay, raw material into finished product by various process, machines, energies, and it is a narrow term. Okay, manufacturing. Okay, and production is process of converting input into output in a broader terms. Okay, it means production. For example, how to say means you can see crude oil production and not crude oil manufacturing. So do we manufacture the crude oil? No, we are just getting the raw material and we are just converting into that. Okay, you can see manufacturing process of converting raw material to finished product, and manufacturing production are interchangeably used. Okay, I think so you can understand. So input means production means such a simple thing, guys. So and in for example, in the toothpaste company, whether they manufacture toothpaste, no, they are production. So toothpaste is being produced and it's been sold to the current market. So manufacturing means it's like we have to just manufacture each and everything. Suppose raw material, we are just converting the raw material into a completely sustainable product. Okay, I think so you got the point. Okay, so you can see in it means in the entire metaforming, so in the entire the production engineering, we are just seeing about the manufacturing, not the production. Okay, I think so you can understand. So production means it will little bit of other extra thing, so it doesn't want that much, I think so, in my point of view. Okay, so next thing you can see classification of manufacturing process. So manufacturing process, you can see shaping, forming. It is shaping and forming is zero process, joining process is building process, and removal process is the machining process. Okay, just 1 second. Okay, so next thing you can see removal process is machining process, regenerative process is additive manufacturing process, and you can see regenerative manufacturing production of a solid power, means products in layer by layer or into raw material by different. So it's just simple. For example, if I just tell this paper means, you can see how much a thin layer is been there. Okay, I think so you can see thin layer, but whenever I just arrange it like this, you can see how much complex layer is been there. Same like that, the regenerative manufacturing will be just done. Okay, so next one you can see basic of regenerative. This one is normal thing. So it means I'll just explain this kind of thing in other videos. Okay, so next thing you can see machining is a essential process of finishing by which a job are produced to the desired dimension and surface finish by actually removing the excess material. Simple thing, guys. Mean machining is not a bigger case scenario. For example, I'll just show you a video so you can have a clear understanding. So you can see everything is been machining. You can see each and everything. So you can see this is also a part of machining. So this is the tool we are just using. So you can see this is also a part of machining. So each and every product it means how we are just removing, it comes under the category of machining. Okay, so you can see how much a detailed shape is been there. Okay, so I think so you got the point. Just 1 second. Okay. So I think so you're getting the point. So it means essential product. Okay, I think so. Can answer. Machining aims us to fulfill its functional requirements and improve its performance. Prolongs and drawback is as loss of material occur in the form of chips, and it is slow process. Yes, definitely. Because you would have seen about non-conventional machining before I just uploaded the video. That is so much. It's there won't be any kind of chips being. It means will be there. Okay. So the next thing you can see machine tool. Machine tool is one of the most important. It means I think so. While using the machine, the machine tool is being. So machine tool is a non-portable, power operated and reasonably valued device or system of a device in which energy is expanded to produce job of desired shape and size and surface by removing excess material from the. It will just guys just a simple thing. Machine tool is a simple thing. For example, you can see about drilling machine. It's not like a hand portable drilling machine. The original drilling machine will such a huge bigger size. So we can be just consider the lathe machine. Lathe machine can be moved? No, it is non portable and it is power up. It's definitely power and reasonably value device. Yes, we are just giving so much cost and it has cutting tools. Yes, definitely it has cutting. So lathe. Suppose if you take a portable drilling machine, means that's not machine tool. It's a different kind of thing. Okay, we can see whenever a battery operated pencil sharpener can't be accepted as machine tool. Okay. So it means each and everything has a certain category. Okay, you can see portable, not machine tool, portable drilling machine, portable grinding machine. So these are getting not kind of the machine tool. Okay, I think you got the point. So the other thing is there are quite interesting things in this. Okay, one is orthogonal machine, second one is oblique machine. Because I think so got the point. So orthogonal machining and oblique machining are quite two different things. Okay, so before going into that. Okay, so we will see about this one. Okay, so you can see metal cutting without deformation. Metal is definitely without deformation. Metal removal can't be take place. So deformation entirely here plastic only. So here there no elastic deformation is occurring. Here entirely plastic deformation occurring, and according to the plastic deformation only each and every material is being removed. Okay, I think so you got the point. So metal cutting, you can see metal cutting or machining is a manufacturing process in which material is deformed plastically with the help of machine tool and cutting tool. Removal of material takes place in the form of chips. Okay, cutting tool HSS and machine tool is lathe machine. Okay, you can see definitely the cutting tool material will be so much hardness will be greater than the workpiece. Okay, workpiece material. Okay, if workpiece material is greater than cutting tool, definitely here the cutting tool will have premature death. It means cutting tool won't last for so much time. Okay, you can see 33 hours may be reduced to 30 minutes. Okay, so cutting tool material should be 40% harder than the workpiece material. Okay, I think so you can see this one. So next thing you can see cutting tool is one of the what is this I think so, okay, which comes in a direct contact with the workpiece to deform plastically. Hence, the compelled tool life and the tool material should be harder than the workpiece material. Okay. Okay. So you can see like this only most of the drilling tool will be. This is the drilling tool. Okay. You can see here different point is being there. So it is multi cutting. So it is multi-plate cutting. It is multi-point cutting and single point cutting. Multi-point cutting is also there. Okay. I think so you can answer. So you can see this kind of thing is a milling machine. So here multi-point cutting will be there. Okay. But it can be also cut at a different side. Yes, definitely. So single point means okay. See guys, I'm just writing in a pen. So this is a one tip. So according to one tip only I'm writing. So suppose if I just added like this, so you can see if I just added like this means you can see it is comes in the category of multi-point. That's it. So single point means you are just using the single tool and multi-point means you can see you are just using the multiple tool. Okay, you can see, I think so you can understand. So we can just write it. So you can see, so this is a multi-point cutting tool. Okay, so if I just wrote only according to red pen means it is a single point. So if I am using different tool it is multi-point. Okay, that's it, simple. So but it means in the single point I will just write like this and I will just write like this, I will just write like this, I will just write like this. So different angles we are just using. Okay, single point. I think so you can understand. So cutting tool you can see single point cutting tool, turning tool, facing tool, boring tool, and thread cutting and shaping, planing and slotting tool, parting tool. Okay, and multi-point you can see milling cutter and drill bit cutter and branch as well as hacksaw blade and grading tool. Okay, I think so you can understand. So next one threading. So you can see this kind of things comes under threading, and partings cut the workpiece into V shape, okay, like this. So we place the material, it means tool here, and we'll just cut, okay. So next one you can see grinding. So while using the grinding, emery paper, like I think so we are known about the emery paper. So and in the grinding, silicon carbide and cubic boron nitrate are literally being present there, and they will convert into powder, and we just put on the paper and it will be just stick. After that we are just using. So I'll just explain you this kind of things in another way, okay. So this is the most important thing, okay. So for example, before showing here, I just want to show you lathe lathe machine tool. I think so you can see this one, okay. Tools, okay. I think so you can see this one, guys. So like this only each and every wait, I'll just put in 3D. So you can see this one. So like this only the entire thing will be, okay. I think so you're able to see. So you can see here, you can see like this it declined, and here also like this it will decline. So you can see it is not a plane surface, it is been declined, okay. You can see different shape is been there, okay. So like this only the generally the drill bit will be, okay. So you can see this one. So each and everything is not a planar surface, it's an inclined surface, okay. So you can see this one. This is a representation model of this, okay. So you can see it means 0 1 and 0 2 all are cutting edges, okay. And 0 1 is called as, it means this side is called as side cutting edge or main cutting edge, okay, or primary principal cutting edge, okay. I think you can understand. And 0 2 is called as this one. 0 2 is called as end cutting edge, okay. And this O, it means this 0 is called as radius, it means radius of curvature, no radius you just say, okay. If 0 is sharp, it breaks, and U, it means workpiece not uniform, okay. It should be blunt, it means, I think so you can able to see this one. So is this any sharp? No, it is little bit curved, okay. Okay, I think so you can understand. So you can see in this 0 to 1 is a cutting edge, okay, it is side cutting edge, and 0 to 2 is end cutting edge, okay. Here it will be, it won't be sharp, but it will be little bit, it means the radius will be like this, okay. Okay, I think so you can understand. So next thing you can see, when O is sharp, we make little curvature, and the end cutting edge little bit contact. So the end cutting edge also little bit contact will come while it is being machined, okay, workpiece, okay. So end cutting edge is called as minor or secondary cutting edge, okay. I think so you can understand. So the next thing you can see, when and why this top surface is not given, it's so much inclined in upper way, and we are just going in a bottom way, means whenever we just give this top surface in an inclined way like this, it means instead of giving, it means mostly this surface will, this surface will be like this, okay. We won't give like this, okay. So why? Because the chips will come here, and it will just go and fall, it means it will just come here, chips, and it will go and fall in the back to the workpiece also. So that's why we are doing, so the chip will just flow like this, okay. I think so you can understand, okay. So you can see the face or rack face, it will just move, and slope should be, okay. And chip curls, and you can see top atom also, bottom also will be there, and the top at the top no contact will be there, okay, it is unstable, and the bottom also will be no contact, so it is unstable, and the middle portion will be stable. So this top and bottom may tend to flow anywhere, okay. So to become stable, the top portion and the bottom portion will try to come towards the center. So the while it's been coming towards the center, area tends to be reduced and try to become stable, and minimum energy consumption will occur. So as the top area first contacts, and the area first reduces, the surface tension occurs first, okay. So this area, okay, this area comes contact with the tool at the first, okay. So and then the down, it means down area will come in the mixed, okay. So there will be a difference in the top and bottom area. This leads to curling, okay. I think so you can understand. Due to the surface tension only, the curling generally occurs, okay. So while chip comes out, it makes contact with the workpiece and cutting mill, and it may erode the workpiece also, okay. I think so you can understand. So tilt the rake face angle, and so that the chip doesn't contact with the workpiece and tool, okay. So I think so you can understand. So you can see this face is called as end flank, and this side is called as side flank, okay. We don't make contact with the workpiece, so If there is a rubbing takes place, we slope them. Okay, chip should be move away from the machine tool. Yes, definitely machining should come good. Okay, you can say only cutting edge should be exported to our piece. Okay, I think so I can understand. So in generally here three faces will be, okay, front, side and top. Or three faces will be. In the three faces, six angles will be. It means one faces two angles and three faces six angles will be. Okay, so you can see to ensure the chip flows occur on the machining zone, only the cutting edge is exposed to our piece, and the three surface rake, side and end flank are sloped in two different directions, and hence each and every slope has two different angles. So there are six angles to define a tool. Okay, when the six angles of the tool along with the nose radius is written, it means six angles along with the nose radius is written. It is called as tool signature. Okay, so one surface, three angles. Okay, I think so you can understand. So you can see this is the normal thing. You can see here we are just relating in a different way. Okay. Generally the main cutting, it means main cutting or side cutting edge will be directly contact. So we slope here. Okay, so it means slope leads to non-touching of the workpiece and no direct contact of one piece. Okay, I think so you can see this one, guys. So each and everything we are just sloping. Suppose I'll just show in 3D way. Just one second. The 3D all alone it's not coming. What the problem is here, I don't know. Anyways, I think so you got the point, guys. So different angle will be, I think so you can understand. So you can see this one is being inclined in this direction, this one also inclined, this one also inclined. So different size will be, that's it. Okay, so you can see we have main cutting edge, it's a little loads will be, and rake face, side face and end face will be. Okay, end flank will be and the side flank also will be. Okay, so you can see six angles and no series we write predefined, so it is called as tool signature. And rake face you can see mainly chip and tool, no contact. Okay, chip and tool no contact, and we provide, okay, side and end flanks workpiece and tool no contact. Okay, see guys, it is rake face. Okay, rake face mainly chip and tool no contact. Okay, and side and end flank workpiece and tool is non contact. Okay, I think so I got the point. So only main cutting edge should be connected to little radius. Okay, we can see this is AESA tool signature. So first one is the back rake angle, BS. Just write it down. Suppose in the question if they ask the ASA tool signature, means you can write back rake angle, side rake angle, and end relief angle, and side relief angle, end cutting edge, side cutting edge, and radius. Okay, so I think so you can have back rake angle, side rake angle, end relief angle, side relief angle. This one is end cutting edge, side cutting edge, and radius. Okay, nose radius. Okay, I think so, you got the point. So simple, BS 2 times of ES and N, okay. So guys, this kind of thing I just learned from my other teacher, okay. He is also one of the great teacher. So, and that's our name is Rajiv Singh sir, okay. So from him also I just learned a little bit of extra things, and most of the extra things from manufacturing technology, especially in the production engineering, okay. So AESA means you can see American Standard Association, okay. Mostly we represent each and everything with the American standard thing, okay. So I think so, and American standard and ASC signature basically referred to as machine reference system, okay. So angle is always measured with reference to the same plane, okay. You can see this is x-axis, y-axis, z-axis. According to this axis we are just measuring each and everything, okay. Each and every phase we measure with the same reference angle. The reference phase will be different, okay. So if we measure the three phases with the machine axis, it is called as reference plane. This is called as ASA tool signature, okay. So if reference plane is not a machine axis, then there is other kind of tool signature. That's a different thing, okay. I think so, got the point. So it means just 1 second. So I think so, you can see this one. So like this only the entire thing will be, and like this it's seen in the top view, okay. Top view, this is side view, it means this is front view and this is side view, okay. You can see in this side view, you can see this is back rectangle and it is end relief angle, okay. End relief angle. So this is back rectangle, this is end relief angle, okay. So you can see at the front angle, this is side rake and this is side relief, okay. It means this entire downside is called as relief and this topper side is called as side rake angle, okay. And the top surface you can see this is side cutting edge. Entirely the side cutting edge angle only we'll just machine. So end cutting edge we generally don't machine because it's secondary axis, okay. Okay. So you can see machine reference. According to machine reference system, we are just taking the system means it is ASA. It is American Standard Association. If tool reference, according to tool you are just taking, it is called as ORS as well as NRS. Okay. So I just explain this kind of things in later on videos. Okay. I think so you got the point. So you can see this is back rake angle and side rake angle. So back rake angle and side rake angle will be other topper portion. Okay. So so I think so you're getting the point, guys. So simply you just remember this one. So in the top side just draw the diagram. Draw the diagram. So okay, like this it will be there. It is no status and like this. It means selective bit of tilt. Okay, you can see this. This is side cutting edge. Okay, you can see this is, so this is end cutting edge. Okay, end cutting edge. Okay, suppose if like this means that means you can see this one is side rake. Okay, side rake. This is side relief. Okay, and the next thing is like this. So this is back rake and this is side, sorry, end relief. Okay, end relief angle. Okay, I think so I can understand. Okay, so now we can just go to the basic. Okay, so now we are just going to see about the orthogonal machining. So there are two kind of things. One is orthogonal machining, second one is oblique machining. Okay, so orthogonal machining is really two dimensional and oblique is 3 dimensional. Okay, I think so got the point. So orthogonal is so much simple, guys, because I'll just show you the thing. Okay, so you can see this one. So you can see in this an angle is been inclined. Okay, but here you can see no angle is been inclined. It's about straight line. Okay, and you can see only two forces is been there. Okay, feet, it means thrust force as well as the feet force. But you can see in the oblique machine 3 forces are there. Okay, you can see yeah, cutting force, thrust force and feet force. So 3 forces are there. Okay, so it's 3D and this is 2D. That's it. So I think so you can see only this means straight line and only this is inclined. That's it. So no bigger difference. Okay, so each and everything is same. Okay, I think so you can see this one. So you can see This is shining surface, okay. Tool material, this is tool, and this is a workpiece, and the shear angle will be okay. You can see here it's been I'll just zoom a little bit. So you can see here if we are the best, it means cutting, and here is about shear angle and shear plane. This is entire, this plane is called shear plane, okay. Entire plane is called shear plane, and this is chip and rough surface. Here the rough surface will be in this it will be shining surface. This is tool, and this entire thing is a rake angle, okay. This down portion is a flank and relief or clearance angle and shear angle, each and everything is there, okay. Here this is cutting tool, and this is it means chip thickness. Definitely the chip thickness will be greater, okay. When you compare this thickness, okay, this is only the breadth and this one is the velocity, and this one is the shear plane is also important. Rake angle and cutting tool and these is important, okay. So you can see rake surface and flank. So the rake surface, okay, the surface along with the chip moves upward is called as rake surface, okay. Next one is the flank. The other surface which is relieved to avoid, it means you can see at this bottom edge it is so much relief, so they don't have enough chip surface, so it is called as flank or relief surface, okay. The next one is rake angle and clearance angle. So rake angle is this one, clearance angle is the bottom one, okay. You can see angle of inclination of the rake surface from the reference plane, okay, normal to the horizontal. So it allows the chip for direction, okay. It provides the sharpness for the cutting edge, definitely, and it reduces the cutting force power required to shear the metal and reduces power consumption. It means depending upon the rake angle also we are able to do different things, okay. So you can see thickness of the chip is always greater than thickness of the this material, okay. I think so you're able to understand. So you can see rake angle and clearance angle. Rake angle, you can see angle of inclination of the rake surface from the reference, okay. So in generally orthogonal machining, the this thickness will be depth, okay, d, okay. I think so you got the point. So next thing you can see t equal to f of sine, it means sine, it means lambda. So this is generally turning for the oblique machining, okay. It means I'll just tell you later on, okay. Next one, you can see orthogonal turning t equal to f of sine 90, okay. So this is okay, this is okay. So you can see which one of the following statement is not correct with reference to purpose and the effect of angle content. To get chip phase, definitely will be to reduce the friction. So to reduce the friction is it's come as clearance angle. To sharpness of cutting is no. To better, okay. I think you can understand. So if negative rake angle means definitely the heat, it means the heat will be so much high, okay. The thermal efficiency will also so much high, but when it's positive, the thermal efficiency will be so much high, okay. So you can see cutting power consumption in terms of turning can be reduced by you doing the rake angle, okay. Increasing the rake angle, it means it reduces the cutting force, but okay. So whenever you just increase the, it means rake angle means what will happen, the cutting force will be so much reduced, okay. That's what they are saying. The cutting power consumption in turning can be seen by increasing the rake angle of the tool, okay. Larger angle means low strength of the cutting edge. Oh, yes, larger cutting angle means low strength of the work, yes, correct. So cutting torque decreases with drilling angle, cutting torque is definitely correct, okay. So next one, it is clearance angle. Clearance angle or relief angle, angle of inclination of the clearance or flank surface from the finished surface, okay. It reduces friction and tool wear, okay. It improves tool life, and excessive clearance angle weakens the tool and must be positive, okay. So consider the diagram with respect to relief angle. This affects the direction of the chip flow. This reduces excessive friction between the tool and workpiece. This affects tool life. So this allows the better access of coolant to the tool work place interface. So next one, in orthogonal cutting, shear angle is between shear plane and cutting velocity. Yes, definitely shear plane and cutting velocity. So you can see this is shear angle, okay. This is shear plane and this is cutting velocity, okay. So as I just told about before, orthogonal cutting and also oblique cutting is there. And you can see cutting tool is perpendicular to the direction of the cutting velocity is orthogonal cutting. The cutting edge is wider than the workpiece and extended beyond the workpiece are the edges. Although the width of the workpiece is much greater than depth of the cut. Okay. So the chip generated flow on the rake face, it means tool the chip velocity is perpendicular cutting edge. Okay. The cutting force acts only in the two dimension. Okay, two direction. Okay. So you can see which one of the following statements is correct. Oblique cutting, direction of chip was normal. Okay. Cutting edge is okay, inclined to the acute angle to the direction of the tool feed. Okay, that's it. Okay, next you can just, I'll just zoom a little bit. Okay, so you can see cutting, orthogonal cutting and oblique cutting. Cutting edge of the tool is perpendicular direction of cutting velocity. Perpendicular, you can see it is angle to the direction of cutting velocity. The cutting edge is wider than the workpiece at the extra 3 of the workpiece. And also the width of the workpiece is much greater than the depth of cut. Okay, the cutting edge may or may not be wider than the width workpiece depth. Okay, orthogonal cutting and oblique cutting, the chip generated flow on the rake face of the tool with chip velocity is perfect. Yes, definitely it's an width perfect, but here it's been rake face been just tilted. Okay, the cutting force acts only in 2 dimension, but here the cutting force acts in a 3 dimension. Okay, tool life is less and tool life is more, so that's why mostly oblique cutting is generally preferred. Okay, I think so you got the point. So you can see turning. So turning is not oblique cutting, it is not orthogonal, it is oblique cutting. Okay, just 1 second. Okay, now I think so you can easily able to see this one. Okay. Just make a remote. Okay, now it's perfect, I think so. So you can see the next thing. So mostly they will ask like this kind of question: speed equal to pi d and divided by 60 meter per second. Okay. So you can see speed equal to pi d and divided by 60 meter per second. So pi d and divided by 60 meter per second. Meter per second. Okay. Suppose if you just treat it in a meter per minute means you can see this second will be converted. At minute per meter you can see pi d and minute per meter you can see divided by 1000 also. So feed equal to feed is F in mm per revolution. You can see F into n mm per minute. Okay, so directly F will just write, suppose if you wrote directly F means it is F meter millimeter per revolution. Okay, so next one, depth of cut. Depth of cut d equal to d1 minus of d2 divided by 2. Okay, F1 millimeter per minute. Okay, that's it. So okay, this is answer. So next one you can see carbide tool is used to machine 30 mm diameter steel. Okay, spindle speed. Okay, the cutting speed. So they are asking the V. Okay, V equal to pi d n divided by 60. So meter per meter. Okay, pi d n. Okay, that's it. So put each and everything, you will get the required answer. So 3.14 into 0. So this one into 1000. Okay, this is got the point. So next thing we are just going to see a discussion of the rake angle. Okay, so this is rake angle. You can see this is positive rake angle, this is negative rake angle, this is zero rake angle. Okay, so positive rake angle you can see generally is about 5 to 30. It is reduces cutting force as well as reduces cutting power. Okay, reduces cutting force, reduces whenever the force will be reduced, the power also will be reduced. Okay, positive rake angle are recommended. Mesting low strength material. Okay, mesting low strength material and also low power machines and long shaft of small diameters and setup lacks strength and rigidity, low cutting speed and cutting tool material such as. Okay, you can see generally the carbide tool, the carbon is 0.8% of carbon tool It means V contact and just one second. We generally use yes, definitely high carbon steel is used to room temperature. There reaches the material becomes after our workpiece cuts it. Okay. Oh, okay. I think so you can understand. So whenever 0.8% carbon tool reacts with the 0.3% carbon workpiece, so generally the while cutting the temperature is tremendous. You can see 250 degrees Celsius. So at the time material becomes soft as well as the workpiece cuts the tool. Okay. So during the time you can see speed equal to 7.5 meter per minute, and you can see HSS is being used. Okay, so that's why HSS we are using. You can see HSS is 18% W, it means tungsten, and 4% chromium and 1% vanadium. Okay, so they can withstand 600 degrees Celsius. Okay, things are good. So next one is negative rake. Okay, you can see increases edge cutting and increases life of tool and increases cutting force, requires high cutting speed and requires ample power and heavy impact load. Okay, so you can see this is mechanical and thermally good. So negative rake angle are recommended machining high strength alloy, high speed tool with it means rigidity support should be so much high, and here the cutting tool should be ceramic as well as carbide. Okay, next thing you can see. So generally cutting tool it should be so much stronger. Okay, machining high strength alloy, high speed cutting and with rigid setup. Okay, so brittle both may break at the load levels. Okay, high heavier impact load and please, and here is a tool we just okay there. Okay, so we can just see the question. Increases life of tool, it is a cutting position. Okay, we can see that. So for a negative rake angle, the specific power increase pressure is smaller. Oh, no. Pressure will be tremendous high. Okay. Actually, the shear strain undergone by the chip is because of negative rake angle is definitely. So this is the right one. Okay. So next thing, I think carbide tips are generally given as definitely carbide and ceramic. Carbide tips are made from material materials definitely. So brittle material are so much hard materials. Whenever you just compare the different material, brittle material is such a hard material. Okay, so you can see the ceramic tool used in machining of materials have high brittle tool tip. Okay, ceramic tool can be used in the hard to machine work. Okay, I think you can understand. So you can see the negative rake is usually provided on the carbide tip. Okay, so the carbide tip got weak in weakening as definitely. Wait. Oh, it's a brittle. Carbide vessel. It is weak in tension. Okay, brittle materials are stronger in compression. Okay, and brittle materials are weaker in tension. Okay, so you can see brittle material are machined with the tools having 0 S definitely. Okay, you can see provides adequate strength of the cutting tool. Okay, so next one, zero rake. Okay, why the zero rake is preferred? To simplify design and manufacturing in the form of tools. Okay, increases tool strength. So generally the zero rake is used for cutting the, it means infinity of tool material is there, so to cut the tool itself or to manufacture or to machine tool, zero rake angle is generally is being preferred. Okay, to simplify design manufacturing in the form of tools. Okay, so for cutting it is for cutting of the brush with single one cutting tool show vision. So you can see for cutting of brush. So for brush means it is zero rake angle. Okay, to simplify design and manufacturing of the form tool shape tool, it means I think so you can understand. To manufacture the shape tool also we are using the zero rake angle. Increases tool strength, avoids digging of the tool into workpiece. Okay, so single point cutting tool is ideally have generally single point cutting tool ideally have we are using zero rake. Okay, so classification according to the number of major cutting edges. There are a lot of things is been. You can see single point, double point is drilling tool. Okay, and multi point is hopping tool and building and grading vehicle is there. Okay, so which one of the following is single point? So parting tool. Okay, so turning, drilling, boring, milling are commonly used in machining operation. So in this, which is one of the single point? Turning. Okay, turning boring. Okay, for next you can see System of tool memory. Machine reference system is ASA and tool reference system is ORS or NRS. Okay, work reference system is WRS. So this work reference I'll just tell at the end of the video. Okay, so you can see back rectangle. So this is which one is back rectangle? So this one. So you can see it is an angle between face of the tool and the base of the shank and holder. Okay, this is a shank. It is under the back part is shank and holder, and it is usually measured in the plane perpendicular to the base and parallel to the length of the tool. Okay, perpendicular to the base and parallel to the length of the tool. It affects the ability of the tool to shear the work material and form shapes. It in turning positive back rectangle takes the ship away from the machine surface. Okay, takes away. So and whenever the negative back rectangle directs the chips on the machine surface. Okay, I think so you can understand. So you can see the next one, side rake angle. So side rake angle, you can see it is an angle between face of the tool and the base of the shank and holder. Side rake. As measured in the plane perpendicular to the base and parallel to width. Okay, increasing the side rake angle reduces the chip thickness internally. Okay, so you can see the angle of the rake face which is tool base measured perpendicular to base and parallel to width. So parallel to width means definitely it will be side rake angle. Okay. So the purpose of providing side rake angle is to control chip flow. Okay, side rake angle to control chip flow. So next one is end relief angle. So it is angle where push on the end block immediately below the edge and the cutting edge. Okay, it lies in the round the it is usually measured. Okay, so I see each and every time if I just told now itself, you will definitely confuse. So while the video is going, I'll just tell to you each and everything. Okay, next one is side relief angle. Okay. So I think so you can see about the end cutting edge. You can see end cutting edge is the amount that the end cutting edge slopes away from the nose of the tool. So it will clear the finishing surface of the workpiece when cutting with the side rake angle. Okay. So it will clear the circulation with the thing. Okay, you can see it was the trailing edge. It was the trailing edge of the cutting edge of the tool from aging rather than cutting edge angle always weaken the tool. Okay, and you can see it is usually kept in 80 to 50. So it is so the side cutting edge, you can see it is an angle which was okay. So larger is angle the greater the what's you can see it is the larger angle the area the larger angle the greater the area which under the width this test and maybe chart. Okay, it is the angle between the pointing interface of the two workpiece and the beam. And this angle the definitely the starting these kind of things will be just kept on hearing. Okay, you can see as it increases value it will have more strength in line of them. As it increases so you can see 0 surface is disabled when matching caching with the top with the top. You because of this amount, the tool should be okay. Okay, so I think so that's it for this tutorial, and let me see the next video. Bye bye.